In our architecture, various client requests from platforms such as web, mobile, etc. will not be sent directly to the FastAPI server. Instead, the requests are going to be sent to our gateway layer, which is going to be running traffic as a Docker service. This shall be the entry point for all the client requests. Traffic is an open source reverse proxy and ingress controller that makes deploying services and APIs easy. We're going to be using traffic first as a reverse proxy, meaning it will receive requests on behalf of our system and then route these requests to appropriate services responsible for handling the requests. We're also going to be using traffic as a load balancer. A load balancer is a system that distributes incoming network traffic across multiple servers to ensure no single server is overwhelmed. We shall be using the default round-robin algorithm. With round-robin, requests are distributed sequentially across servers. Then we're also going to be using traffic to handle encryption and security via HTTPS, thus ensuring that our network traffic is encrypted. And then next, we're going to have the application layer where our FastAPI server is going to live, also running as a Docker container. This shall be the service with the core business logic and API endpoints. We're going to have an auth module that is going to handle user registration, login with OTPs, password resets, and cookie-based JWT auth. Then you're going to have the bank account module that manages account creation and management. Then we're going to have a transaction module that handles transactions such as deposits, withdrawals, currency conversions, transfers, etc. Then a profile module that is going to handle user profile information and KYC verification. Then you're going to have an AI fraud detection module, which is going to be used for real-time transaction risk analysis and fraud detection. I shall be explaining the machine learning module in more detail in the next video. Then you're going to have a virtual card module for our virtual Visa card issuance and management. Then moving forward, we're going to have a data storage layer that is going to be running Postgres as a Docker container. This layer is going to be used for persistent data storage. We're going to be setting up a primary database which is going to store all our data using Postgres. The data modules we shall have is going to include the user, profile, bank account, transaction, next of kin, virtual card, and the machine learning models. Then we're also going to have a support services layer. And here we're going to be using Mailpit and Mailgun for email sending of our notifications and one-time passwords. Then we shall use Cloudinary. We're going to be using Cloudinary for cloud storage, for user profile images and other documents such as bank statements. Then next, we're going to have an asynchronous services layer, which is going to be this. These services are also going to be running as a Docker container. This layer shall handle all the asynchronous and scheduled tasks. We're going to have Celery workers that are going to handle asynchronous and background tasks that shouldn't block the main application flow. They will process background jobs like email sending, PDF generation of transaction histories, machine learning training, etc. Then we're going to have the Celery bit scheduler that is going to help in scheduling periodic tasks like daily machine learning, training, etc. Then we're also going to be setting up Flower monitoring. Flower is a tool that is going to help us monitor the Celery task execution and performance using a web interface. Then we're going to have a caching and messaging layer. Here we're going to set up support services for data management by using Redis and RabbitMQ. We're going to be using Redis for caching. We shall also use the same Redis as a Celery backend result storage and also use Redis for rate limiting. Then we're going to be using RabbitMQ as a message broker for Celery tasks queue management. Then lastly, we're going to have our machine learning layer. Here is where we're going to define our transaction analysis and fraud detection machine learning services. We shall use an MLflow server to track machine learning experiments, to manage model versions, and to deploy models. We're also going to be setting up a machine learning training pipeline to train and evaluate fraud detection modules. That's it for the overall system architecture. In the next video, we shall discuss in a bit more detail the machine learning pipeline architecture.